Our next speaker is a returning speaker to KBMP. It's Kate Perkins, who is an independent consultant. She's going to give us an update on the report card for the Shasta River. So, Kate, are you ready to present?
Yes, I am here, and I'll go ahead and share my screen. All right, can everybody see that?
Yes, looks great.
Okay, great. Okay, wonderful. Well, yeah, that was a great update on land acquisition in the Shasta Basin. And for this report, Eli Asarian with Riverbend Sciences and myself, my name is Kate Perkins. I'm a consulting scientist. We worked on a broad overview of water and climate in the Shasta Basin. And so we wrote the Shasta River State of the Basin report. And the map here in the background shows the Shasta Basin outlined in gray. And whoops, let me get does that work? There we go. And you can also see, of course, Mount Shasta, as well as the Shasta River, Big Springs Creek, which we will be discussing. And north, the Shasta River flows into the Klamath, and then the basin over here to the west is the Scott River. Just for a broad overview. And this work was completed with the Klamath Tribal Water Quality Consortium. The consortium was designed to inform the public about the Klamath River water quality problems and how to solve them. And it is composed of the five tribes whose logos you see here. And the website for the consortium is listed on this page. You'll find a collection of research affiliated with the group. So, like Randy mentioned, I have presented before. Previously, I presented the Scott River State of the Basin, and this is a continuation of that work. Prior work also includes a report of the Mid-Klamath water quality. And you can find these reports at the web pages listed here, one of those being the KBMP website. So the goal of our project was to, like I mentioned, produce a broad overview of the status of water in the Shasta Valley by analyzing 6 climate and water metrics. And a really important goal of the project as well is to make it accessible to a broad audience. So we made it concise, the format is very approachable, and we were also sure to use non-technical language so that it can be read by anybody. A bit of background about the Shasta Valley. It is a major tributary of the Klamath River, and the basin is located inland in Northern California. And Mount Shasta, of course, is in the basin as well as the town of Wairika, and I-5 goes right through it. The Shasta River, as Amy just discussed in depth, is a major producer of Chinook salmon, and it also supports coho salmon and steelhead. And the Shasta River is currently listed for multiple impairments. There are TMDLs in place for temperature and dissolved oxygen, and it is also listed for biostimulatory conditions. And the hydrology and geology of the Shasta Valley are really interesting. So the groundwater in the valley is fed by the volcanic geology, and this creates these long residence time underground rivers, and the underground rivers then feed cold springs in the basin. And that means that these cold springs have abundant year-round flows, and so there's no need for recent rainfall or recent snowmelt for these flows to remain abundant. And given those low temperatures and the abundance of these flows from the groundwater springs, it means that the Shasta Valley, Shasta River, and its tributaries could provide critical habitat for salmonids in the basin. And in the summertime, when flows are low in the Shasta River, most of the flow originates from Big Springs Creek. And as Amy once again discussed, there's irrigation going on in the valley, so flows are reduced by water diversions as well as groundwater pumping and effects from the Dwinelle Dam and the Dwinelle Reservoir. And the Shasta River, because of the low flows and the lack of streamside vegetation, does tend to warm rapidly as it flows downstream. And this warm water contributes to declines in salmon populations in the valley. And there have been extensive efforts to address these issues with voluntary actions, cattle exclusion fencing, dam removal, land acquisition, like we just heard about, as well as the curtailments and government regulations. And so previously in the Shasta River and its tributaries, in-stream flows were governed by a 1932 adjudication. I'm sorry, a 1932 adjudication governed water, but it did not consider in-stream flows for fish when allocating that water. And so in 2021, the Karuk tribe petitioned California's State Resources Control Board to issue emergency regulations to establish minimum in-stream flows in the river. And this was in response to the drought that was occurring in 2021. And so these regulations were issued as an emergency order in 2021, but they did take full effect in 2022, and they are in effect currently. And what these regulations do is they curtail junior priority water users when in-stream flows fall below minimum levels. And previous studies in the Shasta River have identified flow as an important driver of water temperature. And there are currently more studies underway to better understand the effects of the recent curtailments on water temperature and water flow as well. And so our approach was to analyze these 6 parameters: water temperature, air temperature, river flow, snowpack, agricultural evapotranspiration, as well as streamside tree cover. And we modeled these 6 parameters to better understand change over time. And like we said, just to get a broad overview of what's happening in the valley. Here are the locations of the water temperature monitoring stations that we used. So they go from upstream here at the Big Springs Creek. There's 2 sites on Big Springs Creek, and as well as 4 sites on the Shasta River, with the downstreammost site being just up from the confluence with the Klamath River. And these water temperature data came from the California Department of Fish and Wildlife, Shasta Valley RCD, the Water Board, Karuk Tribe, Yurok Tribe, the Nature Conservancy, as well as Applied River Sciences. And air temperature data we imported from the GHCND, which is available online. And we imported air temperature data for Brazy Ranch and Weed Airport, which Weed Airport is close to the land acquisition that Amy was discussing. And for agricultural evapotranspiration, that is the consumptive use of water in agricultural fields by plant transpiration and soil evaporation. And these data were imported from OpenET. Streamside tree cover, this metric was imported from the University of California, and they calculated tree cover using satellite data. Snowpack was from the University of Arizona's analysis, who used the California Department of Water Resources measurements. And snowpack data were measured on April 1st in this work, whereas all of the other data types shown here were measured in the month of July and presented from the month of July. And finally, river flow is from USGS, and it is from a station that is here at the mouth of the Shasta River, just upstream from the Klamath. We use some simple linear regression modeling to better understand change over time and to calculate decadal changes. So first, for water temperature, it's a bit easier to understand when you have the map and the colors coordinate between the map and the figure. And what we can see is that the most upstream site here, Big Springs Creek at Waterwheel, does tend to be the coldest, and then it gets warmer as you move upstream into the Shasta River, and you can see that same movement here on the map. So it does tend to, as we mentioned, get warmer as you move downstream. And the most upstream site, which is the Big Springs Creek at Waterwheel, has cooled since 2008 at about 1.5 degrees Fahrenheit per decade. And this is likely due to the installation of cattle exclusion fencing in that area, which increases the growth of aquatic plants that shade and cool the water. Then the lower Big Springs Creek Station did cool from 2008 to 2017 before then once again increasing in temperature. And most of the Shasta River sites did cool slightly since 1994. And for the Shasta River sites, the temperature decreased the most at the site just upstream of the Klamath River, just upstream of the confluence. And it is possible that the cooling we see in the Shasta River is due to the water curtailment orders. Increased flow in the river, particularly from the cool springs like Big Springs Creek, could reduce the water temperatures. Now for the other parameters, so for July air temperatures, they have increased over the past 2 decades, and this is consistent with climate predictions both locally and around the world. Increased air temperatures transfer heat from air to the water, and so we typically see warming of rivers and streams because of it. Agricultural evapotranspiration was measured April through September, so during the growing months, and it has declined over the past 2 decades. This is likely due to water scarcity and drought conditions, which limit crop production. Agricultural ET was lowest in 2022, and this was during the water curtailments. It was also low in drought years. Streamside tree cover has declined over the past 4 decades, despite extensive restoration efforts like tree planting and cattle exclusion fencing. And the snowpack in the Shasta Basin can provide runoff and feed groundwater, but data have shown high variability over the past 4 decades. And finally, the flow, which is a measure of water quantity in the Shasta River. While there was no overall change, we can see that flows declined from 1941 to 2021. And outlined here in black are the years where water flows were increasing due to water curtailments from 2022 to 2025. So these are the years where the curtailments were fully enforced. So in summary, despite tree planting and cattle exclusion fencing installation in the riparian zone in the Shasta Valley, streamside vegetation has declined over the past 3 decades. While the cattle exclusion fencing has increased bank stability, the recruitment of new trees hasn't kept pace with the declines that we're seeing in some of the older and existing trees in the riparian zone. And although climate change has increased air temperatures in the Shasta Basin, water temperatures have actually cooled at a lot of sites. And this decline was especially large at the Upper Big Springs Creek site at Waterwheel. And the water cooling may be related to the new water curtailments, which reduce the amount of water used in irrigation. So in-stream flows increased from 2022 to 2025, and those were the years of implementation for the new regulations. And this likely supports cooler water temperatures in the Shasta River. So thank you. That is my talk, and I'll leave these summary points up or see if there's any questions.
Yeah, thanks, Kate. There are a few questions in the chat. Looks like they're getting answered as we go, but
Great.
what's the residence time of the underground rivers?
Oh gosh, that is a question for Eli. I believe that is something that is still being studied, but I'm going to call on Eli for that answer.
Yeah, so um, I don't have that off the top of my head. I think there has been some research that has been done about that in general around Mount Shasta. I don't know if like Big Springs itself has been monitored, but there's certain things you do with like stable isotopes. And if I remember correctly, I think it's some of them are as long as decades, like 20, 30, 40 years or something. But if you look at the spring flows, they do vary from year to year. So I think it's kind of like a blending of, something on maybe an annual time scale up to many decades. But I tried to look for those papers a while ago and I couldn't find them. So if anyone has them, please send them.
Yeah, Amy Campbell said that Big Springs Creek studies quantified 20 to 50 years depending on the spring.
Okay.
Yeah.
Eli, Scott.
Yeah, thank you. I think I have my camera working now. I'm in the Scott River right now. Just kidding. I just wanted to point out the temperature increase in Big Springs Creek is extremely troubling. Just we and it really points to the importance of water management that coincides with water quality outcomes. We should be seeing more cold water flowing from Big Springs Creek with curtailments, and sometimes it doesn't happen. So, just think really interesting findings. I think this just is a great report. So I appreciate y'all.
Thank you.
There's another question on the chat. In regards to the water temperature, did you look at pre-curtailment temperature trends versus since curtailment?
This is Eli's zone.
Well, can you just step back to that slide, Kate, that
Yeah.
shows the July time series for water temperature? So in this project, we looked at it in one more, right?
Oh, sorry.
The water
Yeah, there we
temp.
go.
Yeah.
Yeah.
So you can see it kind of it was kind of bouncing around a lot until about 2001, and then 2002, it went 2002 to 2025. It does seem to be multiple sort of cooler years in a row that normally those coincide with like wet years, and during that curtailment period we had a mix of really of wet years and dry years. So we looked at it in that sense. I'm currently working as part of the Shasta Canyon in-stream flow study. I'm doing some work on looking at some statistical modeling to look at temperatures and the effects of curtailment. So there'll be a upcoming report on that. Doing that with the Applied River Sciences for Trout Unlimited. So in the coming months, there will be a report on that.
Thanks, Eli. Dave Webb, and then Bob.
This is a great summary. I really appreciate seeing something and seeing a presentation on the Shasta Valley, which we don't get too often. In terms of your analysis of shade, were you able to distinguish at all age of the various trees that are creating the shade, since the lifespan of the willows is relatively short, less than 100 years, and recruitment has been virtually nil since the 50s. Are we on the verge of a sort of major collapse in terms of shade of what's left? Or can you tell us anything about, going forwards trends in that?
Yeah, that's a great question. So with these data, we actually were pondering kind of something in this topic, which was how do satellite data translate to what is actually happening on the ground? Because realistically, we're using these data that somebody then used models to extract vegetation type from satellite data. And so we were considering, well, is the model picking up willows as shrubs instead of as trees? And so we actually summed both the shrub and tree vegetation type. All that to say, we can't get that kind of detail from this data set and from these data. We can really just more get a broad look at it. Now, I'm sure if you were to do some kind of study where you took these satellite data and then you took like a pixel of these data and did a few sites where you ground truthed it and like collected data for what were actually there, you might be able to get a better idea. But from this data set alone, you cannot look at tree age or details like that.
Thank you.
Yeah, so someone needs to do a LiDAR analysis, comparative LiDAR, I think would be great.
Yeah.
And that's something Friends of the Shasta River has initiated, but we're a ways off from actually getting it off the ground.
Bob.
Well, I initially had a question on this graph, this slide right here, but I just did want to mention regarding that last comment about trees. Brad Henderson, during the safe harbor process, went through the entire Shasta and kind of digitized all these polygons, classifying and characterizing all the different types of vegetation. He did indicate, I think, whether it was mature or not, or just, shrub or herbs.
Okay.
But anyways, that is out there and it exists.
Okay.
for folks to take a look at.
Could you repeat the name of that one more time?
Oh, his name is Brad Henderson. He heads the Cutting the Green Tape program for the California Department of Fish and Wildlife. I think he's still out of Redding, the Redding office.
Okay, great.
But my initial observation here, I see the chat. Amy asked why that temp was kind of rising on Big Spring's mouth sometime around like 2018 or 19.
Yeah.
And Eli was mentioning that there could be the Big Springs Irrigation District pumping that had influence on that. But wouldn't you see that influence up at the top near the Big Springs water wheel? And I started thinking, I'm like, what happened in 2018? And I noticed that there was, I think that's when it switched over from TNC to CDFNW. So I was just wondering if there's potentially like some changes in land management since that happened that could potentially be associated with the rise in temperature.
Mm.
Yeah, good question. I don't know.
Yeah, I'm not sure.
Eli might have an answer to this. Eli Scott.
Well, I just wanted to point out that there is a data gap at the Big Springs water wheel. So some of those higher temperatures are not really represented super well. So like that big high temperature in 2025, there's no measurement of the water wheel for that. So
Yeah,
just wanted to
really good point. Yeah. Mm-hmm.
Okay.
Yeah, thank you.
And one quick question from myself. Now that you've prepared these report cards for the Shasta and Scott, do you have any plans to repeat this analysis in other subbasins or other stretches of the Klamath?
Another question for Eli.
I think we might go next and update some of the previous analyses, maybe. But it depends on what the tribal consortium wants to do and what their interests are. So,
Cool.
if any of you have ideas, let us know.
All right. There was someone else who had their hand up. I'm not sure if that was covered by my question, but I appreciate the ability to kind of repeat these analyses in a way that standardizes the science a little bit. And I don't know if it's exactly something that would fit into like a data visualization tool, but just have to put that plug in since we were talking about that earlier today, just to be able to repeat analyses over time. This type of tool could be really helpful. Chauncey wants to go into the Sprague for this type of analysis. So.
Great, yeah.
But he's retired now, so he doesn't really have the same say that he used to.
Yeah, Eli and I, when we did the Scott River previously, we did have that discussion of really making sure that we can repeat it for multiple basins. So yeah, Randy, spot on that we had that in mind.
All right. Well, I don't see any other questions in the chat. Kate, thanks once again.
Thank you.
Appreciate it, and looking forward to hearing from you in future years on another subbase.
Yeah.
Right.
Wonderful. Thank you.
Yeah, thanks. All right. For our next speaker, we are going to go into the Salmon River watershed, and we have Stefan and Jarrett